So I have some stuff to say about the quest and in general about our last 3 weeks or so of the semester, but I need some more of the stragglers to come in. So let's just jump in with the new stuff and then we'll talk generally about the rest of the term. So I'll give the quest back at the end of class today. Today we're going to cover graphing parabolas day 2. We've actually graphed parabolas already. It was up here. We're just going to add one small piece to the process, same process that we use to graph parabolas on the quest. It's just one additional piece. And then problem solving. So just some word problems again where quadratics are the things that come out. But today the word problems aren't going to be like when does the ball hit the ground? The problems are going to be when is the ball at its highest point. So highest and lowest is the thrust of these problems here. Also coming up is our review day for test number 2. This is on Friday is our review day. And then the test itself is on Monday, right? And that test, again, it covers more than just a quest. This test covers classes 14 to 26, a whole bunch of stuff. On a Monday, well, that's not how I scheduled it originally. We had 2 snow days, remember? Yeah. So anyway, so this test is on a lot of stuff, and I would not encourage you to wait until Sunday night to start studying for this thing, which is almost on half of a semester's worth of material. I would encourage you to start studying today and tomorrow and Friday. You get the pattern here? Yes. Yes. So start studying and continue studying all the way through Monday. Okay, any questions on the calendar? All right, so again, we're on page 178. We'll quickly run through the demo here. Our summary says in this lesson we solve story opportunities that involve maximizing or minimizing a quadratic equation, and we'll also do a little bit more parabola drawing. Okay, so take a look at this picture right here and put a dot on the 2 x-intercepts of that parabola. And once you've got your 2 dots down, go ahead and write the coordinates. Notice this S, this plural business here. Write the coordinates of both of those x-intercepts. These are 2 separate points. You are writing 4 numbers altogether. What are the coordinates for the left x-intercept? Anybody say 0, -6? Where does that 0 belong? There or in the first spot? There. All right, good. And then the other one is 1, 0. Okay, so far so good. And this is also review, but this point right here is called the vertex. And what was our technique for finding the vertex? Average the x-intercepts, right? That vertex is definitely halfway between this guy and this guy, right? It's perfectly in the middle. So let's just average, and I think that's what we're filling in B. Let's find the x-coordinate of the vertex by averaging. The answers we got in part A, so let's try this. We're going to use this little symbol here, x sub v, to stand for the x-coordinate of the vertex. That's the v. So add and divide by 2, right? -6 plus 1, divide by 2. Nothing new here. We did this a few classes ago when we first drew parabolas. Okay, so this guy becomes -5 over 2, or -2.5. Questions on that? -2.5, does that seem reasonable for where the vertex is located? Yep, looks like that's right. Okay, so so this was all well and good, but finding x-intercepts is typically a long process. It was only easy because I gave you the picture here, right? If I asked you to find the x-intercepts just looking at the equation, you'd say, oh, I'm supposed to change the y into a 0 and then solve that equation, which in this case means factoring, but in other problems could mean the quadratic formula, and you get messy numbers. It's also possible. Imagine this parabola has been shifted 100 units upward. What can you say about the x-intercepts now? There aren't any, but it still has a vertex, doesn't it? So how would we find it if we didn't have x-intercepts in the first place? So here's an easier way to find x-intercepts. To find the vertex that has nothing to do with averaging x-intercepts. So here it goes. For the quadratic equation, y equals ax squared plus bx plus c, the x-coordinate of the vertex is given by this thing, which we'll call the vertex formula. x equals negative b over 2a. Let's use that formula right now. Negative b over 2a. Looking at our original equation, it's up here at the top. How much is b? How much is b? Yeah. Is 5. Just plain 5, right? No x. So when we say negative b, that really becomes negative 5 divided by 2 times, how much is the a? 1. Everybody see the negative b over 2a? And that is negative 5 over 2, right? It's the same negative 2.5 we got before. Do you see the advantage of this formula over our traditional way of first getting the x-intercepts and then averaging, right? Really quick. And the other thing is this formula is kind of for free because you already, if you've memorized the quadratic formula, then you already have this memorized. I'll put the rest of the quadratic formula up here real quick. You don't need to copy this, but negative b plus or minus square root of a bunch of stuff divided by 2a. That's the quadratic formula, right? Do you see the x equals negative b over 2a sitting right there? If we just ignore the plus or minus everything. So you've already got it. It's just part of something you know already. Yes, leave out the discriminant part, and that's the x coordinate of the vertex. Still, we need to find the y coordinate of the vertex. All we know is that this guy lives at negative 2.5 for the x. The y, it looks like it's, negative 12-ish. How would we find it? Well, the same way as before. You got to take that negative 2.5 and plug it in for all the x's in the original equation, right? So negative 2.5 squared, 5 times negative 2.5 minus 6. And you get the y value. Any questions on the vertex? New way to find the old vertex. Okay. So that's fine, fine, fine. Okay, number 5. Yeah, let's get somebody to read number 5 here. Ben. Okay, so we're not going to do any of these in the demo, but you'll do plenty in the activities and then in the homework. But can we just jump a couple of pages ahead right now to the activities, just for a moment? So what I am saying is that a bunch of these word problems from today are really going to mean find the vertex, but none of them is going to be so explicit as to just say find the vertex. The instructions, find the vertex, are buried inside of the word problem. There is a single word in problem number 1. Ramses. No. Yeah, that is the negative 16 is the a, but there's some. Yeah, it's a downward opening parabola, but there's some single word in here that says find the vertex. What word is it? It's maximum. That word right there. That word right there. It's a downward opening parabola. That's what Ramses just said. It has a maximum point. What is the name, the parabola word for that maximum point? That's the vertex. It doesn't say find the vertex, but it means find the vertex. There is a similar vertex word in number 2. Just skim that paragraph. Don't read the whole thing. Just find the word that really means this is a vertex problem. Anybody find it? Largest. That's it. So you are looking for these words now. Biggest, smallest, largest, least, right? Maximum, minimum. These are the words that all translate to vertex, right? You just have to be looking for it. All right, so you'll do these in just a couple of minutes, but let's go back 2 pages, and we're going to do our one more parabola graphing thing. Again, this will be exactly like it was before, but with one additional piece, and we'll get there. So there's a process laid out right there. You can read it later on. We're just going to highlight the one new piece, but let's jump to number 7 where we actually graph this parabola, 4 plus 2x minus 3x squared. Okay, first step is the up or down question. How can we tell if this parabola opens up or down? The A, how much is the A? Is it 4? How much is the A? But A was first, right? A is 4?
Yeah, but isn't always the squared? What your word for
What did you say it was, Lucas? -3, right? Doesn't matter what order it is. It's the x squared term. So in this case, the A is -3, which is a negative number. So is this parabola happy or sad? Sad. So this parabola opens down since A is less than 0. Okay, next step is to find the y-intercept. To find the y-intercept, we let what equal what? X equals 0, right? Done that before. So x is equal to 0. And so I'm just going to substitute all of those x's. They become 0. 4 plus 2 times 0 minus 3 times 0 squared. Notice I always put parentheses when I'm substituting for x. On the quest that, again, I'll hand back at the end of class today, some people didn't put parentheses when they plugged a number back in and made a sign error because that number that is a 0 was a negative, and they missed the fact that it was supposed to get squared. If you're very fancy, you can recognize that the y-intercept is always the c. I'm not that fancy. Okay, so the y-intercept is at c, is the c value is 4, which means the point is what comma what? 0 comma 4. 0, 4. Okay. Okay. Next step for us used to be find the x-intercepts. That's what we did a few classes ago. The next step now is going to be to find the vertex. How come we couldn't find the vertex at this point in our class a couple weeks ago? How did we find the vertex a couple weeks ago? We used the x-intercepts and we averaged them. But now we have a quick way to just find the vertex, which has nothing to do with the x-intercepts. So that's going to be step 3 for us, is to find the vertex. And in order to find the vertex, we have a brand new fancy formula to find the x-coordinate of the vertex. What is that fancy formula? Negative b over 2a. Go ahead and crunch those numbers together. Negative b over 2a. So what do we get in this case? Negative b becomes -2 divided by 2 times a is -3, right? Okay, so we'll reduce this. Let's see, that's a -2 over -6, which becomes +1/3. Okay, trick question. Is that the vertex? What is that? That is the x-coordinate of the vertex. The vertex is a point and it has 2 numbers associated with it. We got to find the other one. When x is equal to 1/3, how do you find the y? You can plug 1/3 back in. Let's do that. I'm going to use the symbol y sub v to represent the y-coordinate of this same vertex. So we're going to plug 1/3 in. And again, I encourage you to use parentheses around each of those x's. Okay, let's do a little bit of fraction work here. It's possible to type this into a calculator. It's also possible to get it wrong when you type it into a calculator. So what do we get here? 4 plus 2 times 1/3. Really common mistake that I have seen some people in this room make is to take that 2 and multiply it by the 1 and the 3. 2 times 1 over 2 times 3. Seems reasonable. Yeah, it's that 2 is squarely on top. If you need to put a 1 underneath it to see it, do that. But that 2 does not hit both. So it just becomes 2 over 3, yeah? Minus 3 times 1/3 squared. What is 1/3 squared? There is a 9. Can't do it out, without writing stuff down, then we write stuff down. 1/3 squared means 1/3 times 1/3. What is that? 1/9. So there are lots of little opportunities here to make mistakes. And if you're ever unclear, this is not just about parabolas, but just in general in math class. If you don't quite know how to do something the way it is, then you got to break it down to something simpler. 1/3 squared. Some of us were trying to grapple with okay, what's the shortcut? What's the formula? I don't know. But if you don't know it, you just write stuff and get back to first principles. So that's 1/9. Okay, continuing to crunch numbers here. Lots of copying. 4 plus 2/3 minus 3 times a 9th is 3/9. Which reduces to 1/3. 4 plus 1/3, I'm content to just write that as 4 1/3. Is that all right? You could go to a decimal, you could go to an improper fraction, but we're going to plot the thing. 4 1/3 is good enough for our purposes. Okay, so that means that the vertex now has 2 coordinates. One of them was, where'd it go? 1/3. And the other one is 4 1/3. So far, so good? So finding the vertex is some work. There's no question. And what? That is the final answer for the vertex. We still have a little bit more to do on this one. But the vertex is a big piece. Okay, we are going to plot that vertex. This is something new now. I'm going to plot that guy, roughly. So plot the point, 1/3, comma, 4 1/3. 1/3, 4 1/3, maybe here. And before we go hunting around for x-intercepts, let's just see if we expect there to be some. Right, because some parabolas don't have any x-intercepts. And if this one doesn't have any, then there's no point spending time looking for them. Yeah? So that's the vertex of the parabola. Does this parabola open up or down? Down. So don't draw this, but I know that the parabola looks something like that. Yeah? Vertex is at the top, this guy opens down. How many x-intercepts do we expect? 2. So we got to go find them. But suppose that this guy right here opened up. Then the parabola looks like that. Does it have x-intercepts? No, so don't waste your time trying to find them. So this is a new piece, and it's written out here in step 4. It says if the vertex is above the x-axis and the parabola opens up, that's the thing we just drew, then there will be no x-intercepts. This is about finding x-intercepts. If the vertex is below the x-axis and opens down, there will be no x-intercepts. If the vertex happens to be on the x-axis, how many x-intercepts will you see? Just 1. But anything else, like this case right here, you will get 2. And so you just pause for a moment, you do this analysis, and it could be you don't have any x-intercepts to find. So again, don't spend your time looking for them. But in this case, we know we are going to have 2 x-intercepts. To find x-intercepts, we set y equal to 0. So I'm just going to copy this thing here, 2x minus 3x squared. Maybe this thing factors. And all the parabolas that we drew the other day, it did factor. But starting today, it doesn't need to, because how could you solve that even if it doesn't factor? How could we solve that quadratic equation? Quadratic formula, right? We'll solve any quadratic equation. We didn't have the quadratic formula when we drew parabolas the other day. So quadratic formula, I'm not going to put the details in here. I'll just say use the quadratic formula, and expect that you're going to get some messy decimals, right? You could get, 4.327 and some negative number as well, right? So again, the parabolas here might be a little bit messier than the ones that we had before because now we can handle that messiness with the quadratic formula. Questions on the process? Okay, so before we jump to the activity 2 pages from now, I just wanted to check in with you guys about the rest of the semester. So let me pull the calendar up here. So we just had quest number 4. Like I said, I'll hand the quest back at the end of class today. The median grade on the quest was a 71. That means half of you did better than 71 and half of you did lower than 71. Now the danger, like 71 seems like an okay, it's like a C minus. It's it's all right. But the danger with 71 being the median in this particular class is that there are no D's in this class. And so our cutoff is not, for passing and failing, our cutoff is not the traditional 63 like DF cutoff. Our cutoff is 70. This is not my policy, this is GCC's. So I cannot give a grade of D in this class, which means that you're either above 70 or you are signing up for this class again next semester. And so I wanted to say that to those of you who are currently on a trajectory to get like an A or a B, keep doing what you're doing. Keep working hard because it's also possible to slip in the last 3 weeks. We've got a test coming up on Monday and then the final exam in like 3 weeks-ish. So I don't want the A's to become B's and I don't want the B's to become C's, but to those folks, just keep working hard. But I have a lot more to say to the people that are on the C trajectory or the F trajectory. There is time to change your trajectory either for better or worse. And it's possible for some of the F trajectories to become passing C's. But in my experience, I've seen a lot more go in the other direction, that the current C's end up sliding, unfortunately, into the F's. And so I'm just trying to make clear to you that for a bunch of people in this room, the next 3 weeks will completely dictate whether you are going to be taking this class again or whether you have finished with this class and can move on to the next math class or wherever you're going after this one, right? For a bunch of people in this room, the next 3 weeks will determine whether you are going to be taking this class again in the fall. Some people, you guys are good to go. A's and B's, you're not going to be doing it again. But for the C's and the F's, there's an opportunity to change the path that you're on for better or worse. In terms of trying to improve your trajectory in the last 3 weeks, you have a lot of resources for this class. You've got the practice packet with all of those practice problems. You've got the packets themselves. You have My Math Lab, which for all the complaints that people make, it's more than just like a place to do homework. Your whole textbook is available there. How much time have you spent reading through sections in your textbook? Some of you maybe have spent some. I'm guessing a lot of you haven't spent any. You've got videos up on My Math Lab. You have practice problems up on My Math Lab. My Math Lab, again, it's not just the place for you to complain about, oh, it's too picky in terms of homework. There's a lot of other stuff that you have paid for to access in My Math Lab. I encourage you to take advantage of it. There's the Math Studio. Maybe for the last 3 weeks of the semester, you can make it part of your regular schedule. 8 to 8:30, I'm going to be over there every day right before class. If that's too early, I'm going to go right after class. If you have a class after this one, I'm going to go at 11 or at 12 every Monday, Wednesday, Friday, and just make it part of your routine. There's peer tutoring. We had somebody come in and talk about that. It's free. It's one-on-one. You can meet with peer tutors a couple of times a week. And again, many of you in this class, the next 3 weeks will determine your fate in this class. And so I just hope that people will take advantage of the resources that they have. I know that some people have been working really hard consistently in this class. I'm guessing that some other people could work harder. And for, I would say, almost anybody in this class, spending more time will almost certainly lead to better results. And so it's your opportunity in the next 3 weeks to decide, okay, is this the trajectory that I'm on? Is that what I'm going to stay on? Or am I going to improve? Or am I going to slide? Okay. So right after class, if you are interested, we can play the what if game where you tell me privately, okay, Ian, what if I get this on test number 2 and I get this on the final exam? What will my grade in this class be? And I will tell you. I'm happy to just play that game one-on-one with people right after class today or another day, right? But I can give you a very realistic sense of what will it take for you to get an A or a B or a C minus in this class, okay? All right. So activity is 2 pages away. Raise a flag if I can help, and I'll give those quizzes out later on.